What separates an AI prompt that gives you garbage from one that you'd actually push to a production device? It's not the model. It's not Opus versus Sonnet versus GPT 5.5 or 5.4. It's 4 pieces. Stick around and I'll show you which 4. Have you ever tried to use AI to help design or even just make simple changes to your network? Or have you pasted configs into ChatGPT hoping that it spits out something usable? It's 11 p.m. You're in the middle of a maintenance window going bad, and ChatGPT spits out 10 things it wants you to fix on your device, 2 of which are probably going to break your network, 3 are noise. The network's down. You don't have time to read through all these and figure out what's important and what's not. And frankly, at this point, you're starting to lose trust in AI as a whole. Does that sound familiar? I've been in IT for 11 years, and over the last 3, I've been heavily focused on how I can use AI to become a better network engineer. Here on this channel, I share what I'm learning so that you can hopefully apply these things to your job, to your life, and help you save some time to allow you to focus on things that are truly important to you. With the help of Claude, I built 15 network engineering prompts that I want to share with you. We will be covering the structure of an AI prompt specifically geared towards networking. We will run 4 of them live against real lab devices. I'll show you the places where AI still gets things wrong, and then I'll show you where you can get this full prompt pack for yourself. You may notice that in half this video, I have a beard, and in the other half, I don't. If that's something you care about, stick around and I'll explain at the end. Okay, so here's an example of what not to do. So we'll just do a show running config. We will copy all of this, and then we will just open up ChatGPT. And I'm not going to run this again. However, I just did a show run here, as you can see, pasted in the entire configuration. And then I just said, fix this config. And I think we can get caught in this trap pretty frequently where we think AI knows best. And especially in networking, context is king. And context is a key word in 2026 with AI, and in network engineering is of utmost importance. If we just tell ChatGPT, fix this config, as you can see here, there's already some issues. So the first real issue that I can see here is it's telling me to turn off NTP for this router, and this router is actually operating as the NTP master. Now, in a real network, you're probably not going to have a router acting as your NTP server. You'll probably use a Windows NTP server or a dedicated NTP appliance. Still, in this case, say I want to have my router be the NTP master. ChatGPT thinks it knows better and says that I should turn this off, and this will break NTP for the other devices that I have pointing to it. The second issue here is the ACL. It's telling me that this web traffic ACL isn't being used by anything. That's fine, and I appreciate its recommendation, but what if I'm preparing for a change? What if I staged this access list and I'm going to be adding it to an interface in a change window? It doesn't know that. It has no context of that. So it thinks that, hey, this isn't being used, we should just remove it. You're in the middle of a change window. The output looks right, so you push it. 4 hours later and many calls later, and you're rolling back. I'm sure by now you've heard the change in mindset from prompt engineering to context engineering. Ultimately, these two things go hand in hand. Prompt engineering at its core is giving enough context in a prompt so that your AI can give you a well-thought answer. The model doesn't know your vendors, it doesn't know your standards, it doesn't know what you've already tried. Without context, it's guessing. A generic prompt gets a generic answer, and a generic answer in networking is a wrong answer. What I personally see changing with prompt engineering as models get better and more useful is that there's less of a need for the persona prompt, which is the role at the start of a prompt. Meaning, when you start a prompt in the past, it was always really important to say, hey, you are acting as a senior network engineer, do this thing. It's becoming less and less important because based on what you're asking, the models are smart enough to know, hey, he's asking a networking question, I should be acting as a network engineer. While the persona prompting can still be useful, I do see it starting to fade, and general context being more important, meaning the details that you give it are more important. Now, there are cases where persona prompting can be more important. For instance, if you're drafting an email and you want the AI to know, hey, I am a finance person drafting an email to my CEO, versus I'm a finance person sending an email to my coworker I've worked with for 10 years. Your tone is going to be different. Therefore, the AI will give you a different type of email to those different people. Note that the prompts here do have persona prompts in them, and that is simply because I wanted to make these as generally useful as possible so that you're not constrained to use higher end models that might not need as much persona prompting. So if you're using a local model or, Olama or something that isn't quite as advanced, it's still useful for you. Now, here's what a prompt that actually works looks like. There are 4 core elements that make a good prompt: role, context, constraint, and output format. That's it. Every good prompt has these 4 elements. That doesn't mean that if you don't have all 4 of these, that you're not going to get the correct answer. That just means that you're not going to get as good of an answer. And in network engineering, you definitely want the best information possible, especially if you're going to be making changes in production that could potentially break your network. So the first one, role. You're telling the model who to be. In our case, you're a senior network engineer with 10 years of experience in Cisco, Juniper, and Arista. You work for a mid-market manufacturing company managing a multi-vendor network. The second one is context. For example, you need to tell AI what iOS version you're running because, as you and I both know, as the code improves or gets newer, the context and different types of commands being run changes. So if you're pasting in a script block of commands that it told you to paste in, it could be wrong because it just assumed you're using whatever software version on whatever vendor, and it wasn't able to properly give you the code. So make sure that you're telling it what vendor you're using and what software or firmware code version you're running. The third one is constraint. This one is actually a superpower, in my opinion. So as an example, in your prompt, say, don't rewrite what's already correct. And if you're unsure or you don't know the answer, say so. If you don't know, tell me you don't know. In general, AI is built to give an answer. It wants to give you an answer and it wants to please its user. So if you don't give it permission to fail, it will just ultimately guess and not tell you that it guessed because it's programmed to give you an answer and it will make its best effort to give you the right answer. But if it's not 100% sure, it'll say, oh, this one looks right. This is probably the answer. In networking, that's not good enough. You need to tell it, if you don't know, tell me why you don't know, and ask me follow-up questions so that we can reach an answer. The last one is output format. For example, in your prompt, say, give this to me in a code block that I can just copy and paste into my device at the end. Sometimes it will just give you text within the chat that isn't easily copy pastable, and there'll be extra spaces, there'll be word formatting. But if you say, hey, give this to me in a code block that is friendly to Cisco devices, it will format that for you. So you just click the copy button, you right click into your SSH session, boom, your config's in there. The important thing here is that you front load your prompt once so that you're not re-prompting over and over and having a super long conversation just to get to the point that you want. You want to get as correct of an answer the first time because 1, it saves tokens, and 2, the longer the conversation you have, the more the AI could get confused. Now, before we get into the lab, let's quickly talk about data hygiene. Here's a quick rule on data hygiene. Most prompts in this pack need real configs to work, meaning real IPs, real host names, real interfaces, etc. Free ChatGPT and free Claude subscriptions train on your data and likely goes against your company's data privacy policies. This is also called shadow AI or shadow IT. In general, enterprise tiers and API keys don't train on data. Most of this pack is enterprise only or API key only type of prompts, meaning a lot of these prompts require you to put in sensitive data that you don't want to give to a free subscription or even a paid personal subscription. You need to make sure that you're following your company's AI and security policies. My general rule of thumb is if I wouldn't paste what I have in my prompt into a Reddit post, I probably shouldn't be putting it into a free or personal subscription of these AI platforms. With that said, let's jump into the lab and we'll run 4 of these live together. So first, let's try our OSPF standardization template. So we'll open up a new web browser and we're just going to go to Claude. And we're just going to use Sonnet 4.6 for this because that is plenty sufficient for this type of task. And we'll just paste this prompt in. And as you can see here, again, I don't want to belabor prompt engineering, what's important is that you give it the context so that the model can give you good information. So here, as you can see, we're just saying, hey, we have 2 Cisco routers. Here's the names. Here's their interface configurations. Here's the task that we want you to do. We want you to generate the OSPF config for both routers, the process ID, the area number, the loopback IPs, passive interfaces, the MD5 authentication config, and we want to advertise the point-to-point and the loopback into OSPF. And then an important part too here is this constraint. So this basically just says, don't do things I didn't ask. It's really important to say, if you don't know the answer, just tell me, because that's where you get hallucinations, is because the AI wants to please you. It wants to give you an answer, and if it doesn't know, it tends to make things up or guess. And in engineering or networking specifically, you really don't want guessing to happen. So if the AI doesn't know, you want to say, hey, it's okay to tell me that you don't know the answer. Just tell me you don't know, and you can either rephrase your question, ask it a different way, or just give it more context so that it knows how to answer. Another important part of prompting is, how do you want your output? The really nice thing about Claude is it is good about giving you code blocks. For example, if you ask it to write you Python code, or if you ask it to write you a markdown file or something, it'll give you that in a code block, which is really easy to copy paste out in the proper format. So here this just says, give me 2 code blocks, one labeled, core router 1, one labeled edge router 1, and each block should be ready to paste. This just makes it really easy to paste directly into your device. We'll go ahead and just run this. And as you can see here, here's our code blocks that we asked for. So we have our OSPF configuration, our router ID, everything that we asked for. You can just paste these directly into your routers. And simple as that, you have your OSPF configuration. So if you're configuring this on a new device, or maybe a vendor that you don't normally use, you can fill out this prompt with all of your information, and it'll give you the commands that you need to run. So this is helpful, again, for when you're trying to configure OSPF or features on a device that you don't normally work with, and you maybe know the technology, like OSPF in this example, but you don't know the exact configurations to run, and you don't want to spend a bunch of time Googling or on vendor documentation. You can just put this prompt together and it'll give you the commands. If this is the kind of practical, no hype AI content that you find useful, I encourage you to like and subscribe. My goal is to make content to allow you to be more productive as an engineer and get more time back in your pocket to focus on the things that you care about. If you do subscribe, my gift back to you is a promise that I will always work to make useful content and improve the channel to bring the most value to my fellow network engineers. So next we're going to take a look at the ACL auditor prompt. And if you want to pause this and try to figure out what's wrong in this ACL, you can do so now. So we're going to grab the prompt. I'm going to go back to Claude. We're going to paste this prompt in, and as you can see here at the bottom, we just need to paste our ACL in. So we'll go back to our notepad, grab this, paste this in here. And as a quick review, this just says, hey, we're applying this ACL inbound. It gives it some information, says review the ACL, identify any bad entries, do not suggest rewrites of entries that are already correct. If you're unsure whether a rule is correct, say so, and then cite the line number of every issue you find. And again, we tell it to give us the output format. So in this case, we want a markdown table with columns, line, rule, issue, and recommended fixes. So we'll go ahead and run this now. So as you can see here, it found an issue with line 3 because, again, we're permitting any traffic on port 22, and then the next line says permit traffic only to this host on port 22. This rule will never get hit because this is going to override it every single time. So it calls that out, and then it calls out that line 7 basically just negates the entire ACL because we're permitting any traffic, and that's a big flag, a big finding there. And again, these are just basic examples, but you kind of get the idea of the power of what this can do and how you can just do ACL reviews before you put them into production. Okay, so the next test that we're going to do is a runbook generator, and I already have a script for this in my last video, but this can just be a one-off if you need to send information to tech support or if you just need to get a one-off runbook. So we're just going to open a new session to our core router, and we're going to do show tech, and then we're just going to save this output into here. And then we're going to go back to Claude, and we're going to paste in our documentation prompt. We're actually just going to put here, see attached log, and then we're going to add the file, and we'll just attach our terminal output file here, and we'll run this, and we'll just let this keep running here. Okay, so we have our runbook, and here's the two big findings. As you can see, we have some OSPF instability, and it's calling out this ACL that we found earlier. There's some hardening gaps that it found, and here on the right side, we have our actual runbook. So flag 1, we have OSPF adjacency instability. It tells you, some recommended actions to get it resolved. We're advertising a LAN. This is just our loopback so that I can connect from my local network into my lab environment. So this isn't a big deal, but in a production environment, that could be an issue. Calls out this ACL again. The exec timeout is set to 8 hours. That's just so I don't get logged out all the time. But in a production environment, you might want that lower. And that we have HTTP server enabled. But we're not using that, so we should probably go ahead and disable that. Okay, so next up, we're going to use our OSPF troubleshooting stepper, which will fix OSPF issues for you. So in order to fix OSPF, we need to first break it. So let's log into our core router, and we'll just check the current state of OSPF. So let's do a show IP OSPF neighbor. Here's our neighbor. State's full, everything looks healthy. And let's go ahead and open up our CML lab so that we don't get disconnected, because as soon as I make this change, I'm going to lose access to my edge router, just because if we break OSPF, again, I'm sitting here down on this external connection. This external connection basically connects to my PC. I go up through the switch, through the core router, and then to the edge router. So if I break OSPF between these two routers, I'm obviously not going to be able to get to this edge router. So we'll just make these changes from CML for the sake of this lab so that you can see what happens. So we're going to log into the edge router, and we're just going to change the MTU on the interface that sits between the two routers, which will break the OSPF exchange packets. We'll go to interface E00. We're going to do IP MTU 1440, and then we'll clear IP OSPF process. We'll do a show IP OSPF neighbor. As you can see here, we have now lost connection. And if I go back to my MOBA session, I'm not able to connect to my edge router anymore. If we go here to our core router, we'll do a show IP OSPF neighbor, and it's sitting here in state exchange. So we've effectively broken OSPF. So now let's see what Claude can give us to help us fix this. Okay, so I'll grab the prompt we're going to use. We'll come back here to Claude. We're going to paste this in, and this wants us to run show IP OSPF neighbor and show IP OSPF interface E00 on the core router. Okay, so real quick, I just wanted to point out that I did go back and fix this prompt after recording the video. I didn't include enough show commands as part of this prompt. I did fix in the prompt pack. It will now request that you run show IP interface and show run interface, and you'll see why this is important later on. I just want to let you know that I did fix the prompt so that when you use it, you shouldn't run into this issue. Okay, now back to our regular scheduled programming. So we'll go back to our MOBA session. We're going to do a show IP OSPF neighbor, and we'll do show IP OSPF interface E00. Copy this output as requested. Go back here, and we'll just paste this in. And then, again, so here's some context of the prompt. So it says we have two routers point to point. Give some information on the OSPF area. Adjacency isn't coming up. I ran show neighbor, show interface. This task part is important because it helps show in the chat what it's doing. And then again, constraints, and then the output format. So we'll just go ahead and run this now. Now just imagine a situation with me real quick. You're a network engineer and you're troubleshooting this issue. That edge router has gone offline and you can no longer reach it. I would normally say you should run these commands on both devices and then give that information to your AI. However, in this case, you can only reach the core router. You can't reach the edge router because OSPF is broken. So in this case, it's kind of making some guesses based on the two commands that we run. So you can see here, it says we don't have OSPF interface for E01, which is the other side. So the root cause could be anything. It says it could be the wrong interface, MTU mismatch, timer mismatch, network type, etc. And interestingly, its first hypothesis is that authentication is misconfigured. Now, in this case, we are using authentication for OSPF in our lab, but I think you'd know pretty quickly in your environment if you're using OSPF authentication or not. Its second hypothesis is that there's a network type mismatch, and this just says, hey, run this command that we already ran. The next hypothesis is the MTU. So we'll go ahead and just run this command that it's suggesting. We'll paste this in here. And we'll just hit send. And here it says that rolls out the MTU mismatch on the core router side, but one side it doesn't close step 4 yet. So it still wants us to check the MTU on the edge router side. So in the real world, really at this point, you'd be kind of stuck because again, we changed the MTU on the remote side and we can no longer connect to it. Sure, I could jump in my CML lab here and just change it or run these commands, but let's think in real life. If you're an hour away from your data center, you're gonna have to drive there and run these commands. What I like to do is I'll say, hey, give me a list of commands and steps and tasks that I need to do when I get there so that I'm not wasting time. Sometimes it can be a pain to get connected to the network at your data center provider or get your hotspot connected. So just give me a list of these commands. I'll console into the switch. I already have them in a notepad ready to go. Maybe I can get it fixed quicker than worrying about getting connected to the internet and chatting with AI. So I'll just say, I have to drive for an hour to get to this site and check the status of this switch. I can't connect to it remotely, so please give me a list of tasks and commands and things to run when I get there so I can quickly get to the bottom of this issue. And here it wants some additional questions. So we'll say yes, we'll have console cable. And then let's assume that we have VPN access and that we could also connect to the core router if it's not on site at that data center. So we'll say yes. And current adjacency state, we're going to say that it's still down. Okay, so far this has actually been an interesting example because we changed the IP MTU, which is the layer 3 MTU, which is what OSPF will use for its exchange packets versus just the layer 2 MTU, and it actually hasn't caught that yet. So in this example, this just wants me to show the MTU. If we run this command, you'll see that this is just the layer 2 MTU. Show interface E00, include MTU. This is still showing 1440, but if we do a show run int E00, you can see here we set the IP MTU to 1440. Now, if we check our OSPF neighbor again, this is the state it's stuck in, so it's effectively broken. But again, so the MTU on the interface is 1500, but the IP MTU is 1440. Now, Claude isn't actually catching that. It hasn't asked us to do a show run MTU. It just says show interface MTU. So it's just going to keep getting confused. Now, this command would actually fix it because that just says ignore the MTU. But I want Claude to give me the right answer. So to actually show this, we would need to run show IP interface E00. Space this out. So again, in this case, AI can help us, but we do still need to apply our engineering mindset to these problems, and it gives you a good starting point, especially when, again, there's a major outage and you're not sure what's going on. I'm just going to grab a screenshot of this. We'll paste this over here, and we'll see what it recommends that we do. Okay, so it says, our MTUs are misaligned. It wants us to do the show run, which we already did. So what are our fixes here? So the two fixes are just ignoring the MTU, or we could get rid of the MTU command on this router here, which we'll just do that. So we'll just do interface E00. We'll do no IP MTU 1440. And then we'll do a clear IP OSPF process. And then we'll do a show IP OSPF neighbor, and we're back in a full state. That is the workflow, and that is how a network engineer uses AI without getting burned. The main takeaway from this video is never push AI output to a production device without reading what you're pushing. If you don't understand what you're pushing, just ask. Say, hey, what exactly does this command mean? It will explain it to you. AI is a force multiplier, not a replacement. You're still the engineer and your name is still on the changes you make, meaning the good changes and especially the bad changes. Here's the thing I think most people get wrong. If they get bad output, they think that either the provider or the model is the problem. Ultimately, what the problem is your prompt, that you're not giving proper context in your prompt. The full 15 prompt pack is free at GTalksTech.com, and I'll have a link to that in the description below. Every script has a safety label, meaning whether it's safe to use in public AI or a free AI chat, or whether it's something that needs to be used in an enterprise or data privacy regulated platform. Again, most of these will need a paid enterprise subscription to safely use. So let's quickly recap what we did. First, we broke down why generic prompts typically fail on most network devices. Second, we covered the 4 elements that make up a good prompt. That is role, context, constraint, and output format. And third, we ran 4 of them live, and you could clearly see where AI can still get things wrong. If you want a fully automated network runbook and diagram generator, check out my last video and I'll have a link up here. Okay, so if you stayed till the end, you deserve a quick explanation as to what's going on with the beard situation. The short of it is I wanted to take it down a lot for summer, and ultimately the morning maintenance of making it not look like crap in the morning was just taking up too much time. So yeah, so I just cut it down. In the fall, I might grow it back out. We'll see. But this is what you're left with now. I was trying to wait to shave it off before I finished recording this video so that I didn't have a beard in half and had one in the other half. But here we are. Anyways, thanks for watching, and I'll catch you in the next one.